Hi guys, welcome to another exciting lesson for Algebra 1. And today we're going to learn something super cool. It's called cube roots. We don't have an opener, we're just going to get right into the notes. And then you'll have a worksheet for today for homework. So let's get started. All right, so we are going to investigate and take a look at cube roots today. So if you notice that I have written here, written here that it says, and this is how we read it. We say that this is the cube root of 8, okay? Cube root of 8, which also means that x to the third power equals 8. Let me explain. So basically what it's saying is we need a number that is the exact same number and we multiply it 3 times with each other and it gives us 8. And so if we take a look at the x to the third power, right, x cubed equals 8, that's how we say it. We're looking for a number that if we do x times x times x, it gives us 8. That's what's happening right here. X to the third power equals 8. So we have x times x times x. There are 3 of them, and they're all multiplying each other, which means whatever we put in for x, it has to be the same number. So let's start with 1. 1 times 1 times 1 is 1. Doesn't work. So let's try 2. 2 times 2 times 2. So I'm going to write that down. 2 times 2 times 2. Now, 2 times 2 is 4. And 4 times 2 is 8. So it looks like 2 works. So we would say that the cube root of 8 is 2. And we would say that we can put 2 in 4x, 2 to the third power, not that, 2 to the third power, and that equals 8. So those are cube roots. So we can think of like the basic cube roots, which would be 1 times 1 times 1, which is 1, 2 times 2 times 2, which gives us 8. Then it would be 3 times 3 times 3, and 4 times 4 times 4. And so let's take a look at 27. Now, is this one going to be perfect? Or is this one going to give us a decimal? So we have to think about that too. So what times what times what? Same number, right? So x times x times x, and it gives us 27. Well, we just did 1 and 2, so let's do 3. So I have 3 times 3 times 3. Now 3 times 3 is 9. And 9 times 3 is 27. So we would say that for here, the cube root, right, the 3, the cube root of 27 equals 3. For fun, let's just do 4. Let's just do 4 for fun. I don't have that problem made up, but we're on a roll, so let's just do 4. So what if it was 4 times 4 times 4? Well, we have 4 times 4, which is 16. And then if we have 16 times 4, that is going to give us 64. So therefore, we can say that the cube root of 64 is 4. We can also say that x to the third power equals 64, and we know that that x is 4. And we could keep going. We could do it for 5s, for 6s, but I think you get the idea. Okay, so what about 30? So is there a number that I multiply by itself 3 times and it gives me 30? And that answer is no, because we just did it on that last problem. We said that the cube root, right, we had the cube root of 27 was 3. Then we did the cube root of 64 is 4. And do you notice that the 30 falls in between the 27 and the 64? So this is going to be a decimal. Now, if we were to think about what kind of decimal it is, well, 30 is closer to 27. So it's going to be 3 point something, and it would probably be closer to the 3 instead of the 4. So you can type cube roots in your calculator, or you can kind of give an estimate right now what you think it should be. And I'm going to give an estimate. I think because 30 is so close to 27, I think it's going to be like a smaller decimal. I think that t in this problem is going to be about. And when we say about, we do like squiggly equals. I'm going to say it's about 3.1 because it's closer. Now, if you type that in your calculator, it'll give you the exact decimal, but that's what I'm going to say. So anytime that we're rounding, right, or we're doing an approximate answer, we use the squiggly equal sign. That tells the reader, whoever's reading your paper, that you've rounded, that you've cut some of the decimal off, basically, so they know it's not exact, that there is some rounding that had happened. Okay, cool. So let's do a couple different ones. This is no longer cube root. We're kind of back to square root, but I want to show you what happens. What happens if we have the square root of 64, but it's squared? Remember, this 2 tells us how many of the base that we have. So we have 2 of the square root of 64s. So you can write that out. The square root of 64 times the square root of 64. We have 2 of them. And they are multiplying each other. So if we did 64 times 64, that gives us the big square root of 4,096. Now, if we take the square root of that in our calculator, it would just give us 64 for our final answer. Interesting. So basically, and I'm going to show you this is super cool. If you have a square root and you square it, they all go away and you're just left with 64. Does that work every single time? And the answer is yes. Yes, it does. And I want to tell you why, because it's cool. Let me erase this. So let's take something like that we know, kind of a nice number. And this is not a problem. This is off the notes too. It's like fun, cool stuff. Okay, so what if I did the square root of 4? Because we know the square root of 4 is 2. So what happens if I take the square root of 4 and I square it? I'm just left with 4, right? But why? Why does that happen? Well, whenever we take the square root, right? Whenever we take the square root of something, really what that means is it means that that number is to the 1/2 power. So the square root of 4 is really like saying it's 4 to the 1/2 power. Okay? And so if that's the case, if that is the case, if we square a square root, and I'll show you, this is my square root. If I square it, right, I'm multiplying this half by 2, right? And I'll show you that. 2. Now, basically, it's 2 over 1. Oops, I didn't want that highlighted ugly thing. Hold on one second. Let me just erase that. We'll do this. 2. It's really like 2 over 1. And so that means that when I take this and square it, that means that 2 times 1 is 2 over 2, which is 1, which just leaves us with 4. Isn't math so cool? Hopefully it's not making your brain hurt. I'm just doing this for fun because I think it's super cool. So no worries on that, but I did want to show you like where it all comes from. Okay, so let's do the other one. Let's do this one. Let's do the square root of 19 squared. We know that this answer is just going to be 19 because the square root and the square, they cancel each other. But let's do a little bit of the longer way for fun, right? For fun. So that means that I have 2 square roots of 19. Good. And then I know that 19 times 19 is now going to be the square root of 361. And then if you type in your calculator the square root of 361, you're just going to get 19. Super cool. Okay, now I would love for you to explore this on Desmos. I know that we explored on Desmos before, but let's take a look at cube root functions on Desmos. Let's see what happens when we graph a cube root. And so I want you to hop on Desmos, play around with the cube root setting. You just need to make sure that there is a 3 in front of the square root, which now makes it a cube root, and kind of play around with it and see how it is. Okay, that's it. I hope you guys are having a great day. I'll see you next time. Bye.